welcome everybody to AWS User Group Colombo April meeting. So this meeting, our host is Alan Helton. He's a serverless hero and ecosystem engineer at Momento. So our topic is about caching. So I will warmly welcome you all for this meetup, and I'm very excited to hand it over to Alan, and hope you everyone can get an insight how caching can be utilized. So over to you, Alan.
All right, thank you. Okay, so thank you all for joining me on a Saturday. I'm here to talk about the different use cases for caching. I titled my talk, "You do have a use case for caching, and you just might not realize it." A lot of times when I talk to people, they assume that caching is only for databases or for a couple of browser calls. But in fact, there are a multitude of use cases that people don't know about. So chances are, if you're not using caching, you do have a spot for it in your application already. And we're going to cover a wide variety of different types of implementations of a cache, see if we can get the gears turning in your head. So here we go. A little bit about me before I dive into it. My name is Alan Helton. I work at Momento as an ecosystem engineer. I do a little bit of work of solutions architecture, some developer advocacy, a couple other things. Prior to Momento, I worked as pretty much everything that you can do in software development. I was a developer, a lead, development manager, an architect. Have run the gamut on the engineering side. I am an AWS serverless hero, very actively engaged in the serverless community and AWS community in general. Have built up my niche in that area. Most importantly to me, I am a dad. I have two small kids. I have two girls, 4 and a 2-year-old. And when I am not working in serverless and in the cloud, I do have a little ranch where I live in Texas in the United States. I have 32 chickens, 3 turkeys. The guy right there in the picture with me there, his name is Voldemort, and he just became dad this week. He had 11 of his chicks hatch. So super exciting. They decided to wait until I came to London for a conference to hatch. So haven't seen them yet, but will soon. And lastly, kind of on the side, I do Ready, Set, Cloud. So if you've seen anything, any blog posts, or listened to the podcast, or seen the Serverless Picks of the Week newsletter, that's me. That's my blog site. It's Ready, Set, Cloud. So a lot of time and energy in there, just all around, again, around serverless. So let's talk about what we're going to talk about. I'm going to start off kind of high level, just make sure we level set and talk about what caching is, what some of our options are, why we cache. We'll dive in from the beginning at what probably we already know, but we'll talk specifics. What I want to do, one of my objectives today, is to make sure that I put something tangible in your hands. I want you to see how you actually implement things, not just architecture diagrams, but what the code actually looks like of implementing these things. So we're going to talk about the common ones, the database caching and the browser caching. And then we're going to move over to these, what I would consider extended use cases for a cache. Let me pause here. It says my internet connection is unstable. Can you guys still see me okay?
Yeah.
See you.
Yes? Okay. All right. Thank you. Okay. So we're going to talk about some of the extended use cases, look at some code, look at some architecture diagrams in there. And then I'll wrap it up with bring us down to earth with from our excitement and say some things to watch out for. So without further ado, let's talk about caching. This is Mo, the squirrel, Momento's mascot, and he's always very excited to talk about caching. So when I say caching and what the whole talk is going to be about, really the main highlight I want you to take away is that it's temporary data storage. People use it for frequently accessed data. Sometimes they use it for frequently changing data. We're going to cover that in a little bit as one of our use cases. But the reason that they implement a cache just kind of in general is to boost the performance of your application and to relieve database burden. So the IO burden of going and fetching data, especially when it's being accessed all the time and it's a low write, high read kind of operation. If data doesn't change very often, but it's read a whole lot, you can throw stuff like that into a cache to make sure that your app's performing super fast. Just kind of the gist behind a cache, why you would do that is not only for that. Why does it boost the performance of your application? It's because they're super, super fast. They keep data in memory, and they typically short circuit your code by saying, does it exist in the cache? Yes, send it right back. So they're really good for performance. And we talk about serverless in general, performance is everything because it is directly correlated to cost. So that's caching. And specifically with AWS, if you want to know what some of your options are, you have Elasticache. Elasticache has options for Memcached and Redis, both very popular, very well-known caching solutions. You also have the DynamoDB accelerator, or DAX, which is a caching option that's paired with DynamoDB. If you're using that, you can use that for super fast pass-through caching responses. And then the newcomer to the game, and one of the highest, most powerful one I'm most excited about is Momento Cache. And we're going to spend our time today talking about specifics with that and how we can implement that inside of our applications. So now that we know what cache is and what some of the options are, I want to talk specifics about stuff that you probably already know and the use cases that are common when I say caching. So let's talk about that. Database caching is the first thing that everybody assumes, and the one that people assume more than others is read-aside caching. Whether or not we know that term is debatable, but read-aside caching, here's an architecture diagram for what that looks like. So a request would come in from API gateway, triggers a Lambda function that backs an endpoint. And this is a request that fetches data. Let's say we're loading the data about Mo the squirrel. The first thing we would do in our code is go to the cache and see, is that data in the cache? If it's not, that's called a cache miss. And we go to the database to load that information out of the persistent data store. After we load the information out of the persistent data store, we put it in the cache for a future invocation and then return the response back to the caller. So future invocations, any subsequent ones after that, we come in from API gateway, we go to Lambda, and then we hit that Momento cache, or really whatever cache you're using. The cache item is in there. That's called a hit. And then we short circuit execution. We don't need to do any of the database pieces, and we return the response back to the caller. So it's much, much faster. It loads quicker out of the store because it's kept in memory. And then it returns back. So let's talk. We've probably seen a diagram like this 100 times. What we probably haven't seen is the code behind it that makes that happen. So all the code samples we're going to go over today are written in Node.js. I'm using our Node.js SDK for Momento. We do have 7 different languages that we support. We have Node, Python, Ruby, PHP, .NET, and 2 others, Rust and Java. Here we go, Java. So we do have all of those available. I figured JavaScript was probably going to be the one that casts the widest net. I think a lot of people know at least cursory JavaScript. So if we go down here, let's parse through this a little bit. So you can see in our comments here in the code, this is for an endpoint for get/squirrel/ID. First thing we're going to do is we're going to pull that ID out of the path. We're going to initialize our cache client. And part of the constructor in here in our cache client is setting a default TTL. TTL stands for time to live. And what that means is after 3,600 seconds, this is a second parameter, that item, any item we put into the cache is going to be deleted automatically. One of the 2 hardest things in software engineering is cache invalidation, meaning how do you keep it in sync with your persistent data store? And one of the things that we do as a vendor is try to provide you with an easier experience and default the expiration of items automatically. So we do that. We set the TTL. We try to get the item out of the cache. We use the squirrel ID as our cache key, and we're pulling out of our data cache. And when I say data cache, think of that like a database or like a database table. Or if you're more accustomed to DynamoDB, it would be the table there. So we're saying get out of our data cache and get it with the cache key of the ID. So what we're looking at here underneath is if it's a miss, meaning that data doesn't exist in the cache, or if it's not a miss, sorry, there's the exclamation point. It's not a miss, parse the JSON value that we have and return that back to the caller super fast. Doesn't need to do a whole lot. But if it is a miss, if that data is not in the cache, we're just going to go ahead and get that out of DynamoDB. So we're saying dynamodb.send get, and then it's loading the item by the ID, unmarshalling the data, and then we turn around and immediately save that data back into the cache. You see we're saving it into the data cache with our cache key of the ID, and we're saving all the content in there. That way, when we get that second call or any subsequent call while that cache item is before it's expired, it's going to go through this code path, the short one, where it's a hit. We just parse the value and return it. So that's how you implement a read-aside cache with Momento. Let's talk about another very common caching pattern, probably less common than read-aside, but one that's super important when you're talking about cache invalidation and keeping your cache in sync with your database. So this is the write-aside cache. This is how you actually keep that data up to date ahead of time. You don't want cache misses. So really what you want to do is keep your cache up to date as much as possible. So what that would look like in a serverless AWS architecture, request comes in to API gateway, hits a Lambda function. That Lambda function is, let's just say it's a put. So it's updating the information on the squirrel we were just trying to fetch. That saves in the DynamoDB. And then we have a DynamoDB stream that pushes records out to a Lambda function. That Lambda function will update our cache in Momento. So when we're going to look at some code for this, we don't really need to look at the first part. We're going to look at that Lambda function that receives the event from the handler. So what does that code look like? So remember, the objective of this code is to update our cache so we get as few misses as possible. We saw in that get code that if we have a miss, we have to load the data from the database and then save it into the cache. So we don't want to do that because that takes more time than just loading it out of the database originally. So by implementing a write-aside cache, we're always hitting and getting our data the fastest. So super simple here. It's only 10 lines of code. We initialize the cache client. We're setting the time to live to an hour, and then we're processing the records. Now, one of the things I want to point out here is DynamoDB streams specifically. You can configure them to push a bunch of records in at one time to save on Lambda processing. But when we're talking about updating items into cache, you really want the most recent item. So you have to process things chronologically and in order. So you try not to process things in parallel, so you can always make sure that you're pushing the most recent data into the cache. With a DynamoDB stream, you get one of 3 different types of events. You get remove, modify, and insert. When you remove a record, you're deleting it out of DynamoDB. So in our code, whenever we see a remove, we want to delete that out of our cache as well, because that item no longer exists. We don't want to fetch data that doesn't exist anymore. Otherwise, we're going to be inserting or modifying that data. So we're going to marshal or parse that DynamoDB JSON, the new version of it, and then setting that data in our cache. So you can see that's exactly like what we were doing with read-aside cache. We're saying in our data cache, set the cache key to the ID of the item, and then just shove the item right in. That way, when we do the call for the get, it's already there for us. Okay, so that's implementing a write-aside cache. We've talked about read-aside, we've talked about write-aside. That's database caching. That's what a lot of people think of when they think of a cache. Let's talk about the other side of it. Let's talk about browser caching. So we talked about server-side. This is the stuff that your end user actually is interacting with. 2 types of browser caching. The first one we're going to talk about is HTTP. So these are your API requests that your front end is sending off to your back end. So let's say this is Mo, right? He's on his Squirrel website and he's trying to load his profile information. So he hits the get/squirrel/Mo, which is the endpoint we were just looking at, and the response comes back with this cache control header. So you can see that in italics here, cache control public max age 3600. So public in this case means anybody, any browser can save that. It can cache that inside of the browser automatically. And max age is that TTL, it's that time to live. So we can say for an hour, use this response that comes back, ID mode, type ground squirrel, color gray. So whenever Mo makes another call to that same endpoint, it will use that cached value and not even make a call to your server side. And when we come in, we talk about serverless applications, that's saving us dollars directly because that's saving invocation, that's saving compute time, saving a whole lot, especially on data that's not changing very much. So that's browser HTTP caching. That's preventing unnecessary API calls to go out. That one I would say is probably not the common browser caching method that a lot of people know. The one that a lot of people know, oh, hold on, let me pump the brakes here. Let's talk about implementing that. So the way that you would implement this is our event handler that we talked about before when we were implementing a read-aside cache. It is the exact same. The only difference that we have is down here, this last line. We've now added a headers object inside of our response, and we've passed that cache control header in. This is a standardized HTTP header response header. So browsers know to look for that. They know what to do for that. When they see these values come in, they will automatically handle that caching for you. So that's all you have to do to implement that and make it a little bit easier. If you don't want data to be cached, if say it's sensitive data or PII that you don't want to live on a customer browser, you can set this value to no cache, no dash cache, and it takes care of that. Okay, so let's talk about this other use case for browser caching. It's session caching. This is what people tend to think about when they think about a browser cache. So what is session browser caching? So let's say Mo is working on his, let's say he's just working on some research and he's looking up acorns in the Next.js app. So he has an acorn filter that he said he only wants to see acorns that come from red oak trees. So he clicks on the little filter icon on his little table that has the list of acorns, and he clicks on red oak. Now behind the scenes, what that Next.js app is doing is it's setting that value to the session storage. Session storage is only valid for the time that you're in the application. You can close the browser, you can sign out, you can leave, and that invalidates your session. And the next time you load it up or sign in, you start a new session. But what this means is he can set that acorn filter, he can navigate around the app. Every time he comes back to that page, it's going to load that out of the session storage, that cache, that local cache. So it remembers the settings that he has. So it's a nice user experience. I intentionally left out some of the other implementation details, but this is fetching the session storage, and this is setting that session storage. Okay, exciting. So that's the stuff that we probably already knew. At least at a high level, we knew what those four types of caching were. So we're going to talk about some of these more extended, more exciting use cases for a cache. And notice I'm kind of transitioning my verbiage from caching to using a cache, because this is the other type of ways that you can use one without the stigma of database caching. Let's get into it. The first one I want to talk about is kind of in our gaming vertical. It doesn't have to be gaming related, but it does have a really, really good fit in gaming. And that's chats. That's in-game chats. That's communications of players to coordinate with each other, trash talk, whatever they want to do. What's special about in-game chat is that it really only matters for the duration of the game. Let's say you have a 30-minute game. Let's say we use Acorn Hunts. That's a game that I made for Momento, built on Momento. It's an open source project. We have a bunch of videos on YouTube that walks through how it's implemented using a cache. But it's a 30-minute game, and people just go around and they find acorns. And they get points for that, and they can coordinate with each other. Really, when you chat is a really important part of gaming. You know, it's how you coordinate with each other. It's how you congratulate each other. but it doesn't matter when the game is over. There's no reason to save that off to a database, because you're never going to have value. You can't use analytics on that. You can't do anything. That old chat history from 2015 is not going to do anybody any good. It's just costing money storing that data. So that means it's really good use case for a cache, because a cache it stores ephemeral data. This data is only good for 30 minutes. So what we can do is we can set a 30-minute time to live on all this data. And when that 30 minutes is up, it just goes away. No, we don't need to pay for that storage. Specifically with chat, you want to store the messages chronologically. It wouldn't really make sense if you had a chat room where all the chat messages were out of order. It would be very hard to communicate. It wouldn't make sense. It would be valueless. So we want to make sure that we store things in the right order. And then, of course, it's called an instant message. So it needs to be super, super fast, which is another good use case for a cache. Now, when we talk about all these things in conjunction with each other and talk about what the capabilities Momento has, that's a really good use case for our list data type. A list data type does all these things. It's super fast, it stores things chronologically, and it has a time to live that you can set to expire that data automatically. So let's see what that looks like in JavaScript. So we have our endpoint here, /game ID /messages. So this is adding a new chat message. This would be like what we saw, excuse me, what we saw earlier where they're having a conversation, they were hitting this endpoint multiple times. So we pull the game ID out of the path, we parse the body, and then we're going to create a chat message. So that's the username, and that's the actual message that they type. The username comes from the authorizer context, which comes from their auth token, so we can infer that data, and the message is what they typed. We initialize the cache client down here. You can see that we've initialized the TTL at 30 minutes. So whenever that 30 minutes is up, it's going to go away. So to actually save something like this into the cache, into a list specifically, we use this list pushback command. We save it into our chat cache with the cache key of game ID, and then we save that stringified JSON object of the username and the message in there. We don't need to store time because we're not displaying the time, and it's stored chronologically. So as long as we just keep using list pushback, we're going to keep getting those messages in the right order. If there was a use case where we needed something to go up in the front, we can do that too. We can use the list push front command. So we can add things to the end or to the front of a list. And then our response is just 204, nothing really to return besides, yeah, you're good. That data. So we talked about pushing the data in. Now, if we want to get that data back out, actually meaningful to display that list, we have our get endpoint for /messages. And what we're going to be doing is initializing our cache client. We're not going to be using the TTL, we're not setting anything, we're just getting, but we have this list fetch command, which gets all the items that are in the chat cache under the game ID cache item. That response returns an array of strings. What we're doing is because we want an array of objects, we have to iterate over the strings, parse them into objects, and then we can return that back in our response. And then the front end can say, okay, let me color the username and not color the message. So super, super easy to implement a cache or to implement chat using a cache. You know, the data doesn't need to be persisted any longer than the game, and you can do it with 2 commands on either side, the post and the set. So super easy, super nice, fun use case. So we're going to move to the next one, and we're going to stay in kind of that gaming realm and talk about leaderboards. So a leaderboards, again, just like the chat, typically only relevant for the duration of the game. You can have other leaderboards that are like daily or whatever, but you have smaller scoped leaderboards. You can see over here on the left-hand side that Mo the Squirrel is killing it. And what's different about this, and what's different, the reason I had an asterisk on frequently changing data at the beginning, is that this is always changing, right? This is the game. This is the lifeblood of the game. It's the score. And that's going to be changing all the time. Mo's going to score points. He's going to have points taken away when somebody steals an acorn from him. And everybody's going to be scoring at the same time. And one of the things that makes this tricky is thread safety or working in a distributed environment, because you're going to have inputs come in at the same time that try to update the same value, and you don't want to fetch the score, manipulate it, and save it back, because somebody else could be doing that too. If you both try to fetch the score, manipulate it in different directions, save it back, you're going to end up with an incorrect score. So what we have sorted sets in Momento that handle that all for you. It's thread safe. You pass in a score delta, and we take care of the rest. It's part of that shared responsibility model. So you can say increase the score by 1, decrease the score by 1. Don't fetch, manipulate, and send back. It's just, here's the change that I want to make. And it does that safely for you. So it doesn't matter if there's one person or 50 people affecting the same score at the same time, you are safe. So when we look at the code for adding a point, you have our post. We pull the game ID, we pull the username out of the context, initialize our cache client. And then down here, we have our command sorted set increment score. So you can see that we've passed the leaderboard cache. Remember, these are kind of like database tables. We have our cache key, which is the game ID, and then we have the username. So there is a fourth parameter to this call. It's not required, but that's the score change. If you don't provide the score change into this call, it automatically defaults to 1. So in our game, we only go up or down by 1, so we don't include that parameter. However, if somebody wanted to decrement the score, somebody stole an item, I would probably implement a different endpoint for delete points that adds a -1 into that fourth parameter. That would go right here where my mouse is. But what's really cool about this is that you see you're only passing in the change in the score. And in the response from it, that's where you get your thread safe new value. So you can get your new score.score and pass that into the response. So if I was at 22, like I see on the left, call this is going to respond with a 23. So super cool, really neat. Very, very easy to change scores. Now, a sorted set, these score values are, so they're decimal points. So you can have partial points as well. Let's get. So you have a get here. So I've added points to my leaderboard. Now I want to get the entire thing. I want to see this over here on the left. So we initialize our cache client. We call sorted set fetch by rank. And we pull that stuff, and I want to say, give it to me in descending order. I can say ascending, ascending, but with acorn hunts, the higher points win. So so we're going to pull data descending. If I wanted to have an opposite game where the lowest point wins, then we would do sorted set ascending. We iterate over the values. A sorted set fetch returns an array of scores, which is a float, and values, which is a string. So that's what we're parsing here, and we're turning that into a JSON object by including the rank as well with the index. Then we return that whole thing back. So super easy. Again, like everything that we're doing here is really easy because Momento took away all the complexities. So all these things, all these handlers that we're looking at are 4, 5, 6 lines. It's because the commands that we're running super powerful. So again, using a cache, we're not persisting this to any database. It lives, it's short-lived, only valid for the duration of the game. Okay, so we're going to switch context a little bit. This kind of applies to the gaming world, but it does have a broader scope, and that's user sessions. Kind of like how we were talking about sessions on the browser side. We can implement that on the server side to make things significantly faster and easier on implementers. Our integrators, people that are implementing our APIs. So user sessions store data that's only relevant this time of usage. So if we go back to that game use case, this would be the information around the game that I'm actively playing. So what's the game ID? Where am I located on the map? Things like that. What's my score? So stuff in here is frequently accessed, like the game ID. You need that for everything that you do inside of a game. And then it's frequently changing. If we store things like where you're located on the screen, that's going to change all the time. The thing you do most in a game is move. So if that's constantly moving, it's frequently changing. And that's perfect for a cache because it's not going all the way back to the database. It's just living in this super fast, super ephemeral environment. So let's take a look. Let's take a look. This is a use case for a dictionary, which is another data type that we have that you can cache. In here, we're building up this user session when somebody joins a game. So we hit post /game /game ID /players. And what this is doing is it's setting this object on the user context. So we can say, okay, a user with this username, and again, I get that from my auth token, is joining this game. They logged in at this time, and here's where they are on the map, X and Y. They return a 204 because there's nothing really else to share when you join a game, but this is now our session. What this enables us, let me flip over to another code example, it enables us to infer data to make integrating easier. So I intentionally left this comment up here because I want to talk about it. Post /game /game ID /movements. That's not too bad of an endpoint, but when you implement a user session, it can be easier. We already have stored off the game ID on that user session, so we don't need to provide it anymore because it's inferred with that auth token. It's saved to that username. We get the username from the auth token. So when we get that auth token, we can load the game that person is associated with. So that means we have an endpoint that we could just say post /movements and load the user session data. Really load whatever we want, but we can get that data super quickly. We can have validation in here. So we can say, get a single piece of information from the user context. It's one of the value adds of a dictionary. It's an object store that lets you get single pieces of data across. So I can say, give me only the game ID. I saved other things in there, like the login time and X and Y, but I only want the game ID. So we can say, if that value is not in there, we can return an error message, say, you're not in the game. You need to be in the game to move. And then down here, we can do something very similar to what we did with sorted sets and leaderboards and pass in changes in the movement where they locate on the map and have that updated for us in a thread-safe way. And this command works the exact same way as updating the score. It returns the new value. So I pass in, I want to update this by 1, I want to update this by -1, and it returns what the change was, the change result. Really cool for user sessions. The next thing is IoT devices. And this is something that not a lot of people think about, but is all around us. You are integrating and messing with IoT devices every single day. And you don't know it. Like when I was building this presentation, I was like, oh my goodness, there are so many things. Like I was drawing this little phone over here on the left. I had my phone, I had my front doors sensor, the dog collar, the Amazon Echo that I have in my kitchen. All these things are IoT devices and they all have different statuses. You can see that my phone status is charging, the front door status is closed, dog collar, it's green, so that means it's good, it's connected. And then the kitchen Echo, it's not connected, so it's offline. Those are the statuses. Now, what's cool about IoT devices is that they're always pushing data. They're super, super noisy. But a lot of times, like when we're dealing with status, it doesn't matter what literally everything else was in the past. It's just what was this last value? What was the most current status of this device? So that's a perfect item for just a plain old cache item, what we were doing in our very early examples. So let's take a look at what that is. So architecturally, I just want to make sure we're all on the same page here because IoT is not as common as some of the other backend stuff that we do. But you have your device like phone. It connects to AWS service called IoT Core. Your phone is considered a thing in AWS. It sends messages to IoT Core. IoT Core filters that and transforms into a payload that is triggered, that triggers a Lambda function. And that Lambda function is what we're going to look at for the code. It saves that data off into a cache. So as far as the code goes, it doesn't really get simpler than that. Pull the device ID, pull the status off of the event that was emitted from your IoT thing, and save that into a cache. We know what this line means at this point. We've seen it several times. We're initializing a new cache client, and then we're setting inside of the devices cache The cache key is the ID of the device that sent the message, and the status is the payload that we received. So since we're doing this nice pattern of push and get, let's look at what that get code looks like. So if we have an endpoint that's going to fetch that, we have our /devices/ID/status. We pull the ID out of the path, initialize the client, and just do a get. You can see down here, cache client get, our devices cache. We're going to load the status that we stored for that specific device ID. Now, what's interesting about IoT devices is they don't always emit data. Maybe they run out of battery. Maybe they got obstructed and now they can't transmit over to the internet. So we have a really low default TTL here, that 30-second timeout, where if we don't hear anything for 30 seconds, the status is going to be removed. So if we have a cache miss, we're going to default the status to unknown. I don't know. I haven't heard from it in 30 seconds, so I don't know what it's doing. So we default to unknown. If we have a hit, then we return what the status is out of the cache. So a really easy way to do that. And it's not as hard as people give it credit for. So pretty neat. Now let's extend this use case. Let's take the status, but IoT devices, they also do things. So let's talk about location tracking as an example. So we're gonna take an example with the dog collar. So I press the dog collar on my phone and it loads a map up of where the dog's been. Maybe the dog got out. So I want to see where is he? Where has he been? So I get a map and I see all these things about it. And I just wonder, like, how do we get that? How do we implement something like that? And what does it take? So that's a great question. It saves off, again, an ordered list of event data from a specific device. So in this case, it's storing latitude and longitude coordinates from a GPS tracker that's embedded in a dog collar. So we want to see things like, where has he been and where is he now? So we haven't found the dog, so we want to see, where is he going? And that's stuff that you can do with the cache. You can get real-time updates with Momento and our topics and our event messaging system. Very, very powerful stuff that lets you see stuff in real time. So let's take a look at the code. Let's see how you would build something like that. So this is, again, an example of a list that's going to store that ordered set of data from the IoT device. So this is the same handler we were looking at before. We've just added a couple extra things. So we're pulling latitude and longitude off the event now. This comes from the IoT device. And then we're still setting the status to the current value. And then we're adding values to the list. We're saying push back in our devices cache. We've built this custom cache key using the device ID. We want to save off the locations. And we're going to save a stringified JSON object of latitude and longitude in there. So we can build up this history of pings, basically, from that dog collar. When we go to fetch that data, that get, we're going to do very similar to what we did with the in-game chat, but IoT version. So we're going to do a list fetch, pull the location cache item for that device, parse the strings that come back because it returns an array of strings. We're going to parse that into JSON objects and then turn that back down to the collar. And then at that point, it is up to the front end to implement what that looks like on the map. But we've been able to successfully store and retrieve the GPS values in the correct order. The correct order is very, very important when you're doing location tracking, because if you just had a bunch of random dots, you wouldn't know how to connect them together, and it would look like your dog went crazy all over that map. So the list from Momento is super powerful in that case. This is probably my favorite caching use case, and it's the one that clicked and really made a lot of things click for me. What I call the hold my purse moments. And these are for when you're doing back-end processes and you're working with medium to large data sets. That's obviously a subjective term. So I want to clarify, a medium to large data set is anything greater than 256 kilobytes. And all you need to do is just store that off temporarily. I need to do something else, or I need you to hold this so I can go do something, and I'll be right back. It's something that doesn't need to live any longer than that. Hold this, I'll be right back. Hold my purse. So the reason I want to focus on that 256K limit is because of technical limitations inside of AWS serverless services. I hope a lot of you are familiar when you're architecting designs and implementing software that there are a lot of service limitations with AWS services. Now, they're there for a good reason, but there's some that kind of impact design decisions. SNS, you have a max payload size of sending messages of 256K. SQS, you cannot receive messages that are greater than 256K. EventBridge, you cannot publish events greater than 256K. Even with step functions, one that a lot of people don't know is the data size between state to state when you make a transition. You cannot have that data context greater than 256 kilobytes. It's all, it'll all break. Every single one of these services we see on the screen, if you increase greater than 256K, you're going to run into issues. So this is where a cache comes into play. This is one of those hold my purse moments where I have loaded data that's bigger than 256K, and I just need to pass something else around that's smaller. So what you do is you put that large data set inside of the cache and you pass around the cache key. So you see on our left-hand side, we have an EventBridge message that includes the cache key. And on the right-hand side, we have the Lambda handler that's on the other end of it. And it expects that cache key to be in the payload. So it loads the data out of the payload and begins doing whatever it is it's going to do. Maybe it's enriching data. Maybe it's transforming it. If I need it further down the process, if this is hop 1 of 10, it's going to shove that right back into the cache and pass that cache key along. Now, one of the really cool use cases that I found specifically for this, to put a tangible example in your hands, is an example that I built somewhat recently. I built a Lambda function that communicates with ChatGPT and has a conversation. Now, I used this for a fitness app that I was building. I was asking ChatGPT to build a workout for me, and the workouts were great, but I wanted a warm-up and a cool-down that were relevant to that warm-up. I didn't want to, or to the workout. So I wanted something that warmed the appropriate muscle group up and something that cooled the appropriate muscle groups down when I was done. So I implemented this Lambda function that stored off the conversation that I had with ChatGPT in a cache. I pass around a conversation key, which is the cache key, and I can just keep asking it questions. Let's look at the code, and I'll explain a little bit more. So in the code for this handler, it pulls the chat history out that I've had with a given conversation key. So in the example I was just giving, this is me saying, build me a workout that works out my arms with dumbbells and barbells. And it returns an answer. It comes up with a workout, saves it into the cache, into a list, chronological order. It's very important when you're building a conversation history. So I call the Lambda function again in a state machine, and I prompt it, build me a warm-up relevant to that. And the keyword here is that, because I'm using context. I don't want to pass in the entire workout again, say, build me a warm-up for this. I want to just say that to make it a lot easier. And ChatGPT knows the context. So it loads that previous conversation of me asking it for a workout, its answer, and then I pass it in another question that says, give me a workout or a warm-up for that. So it saves my new message into a list, pushes that into the cache, along with the answer of ChatGPT. And I can just keep calling this over and over and over again. I could say, build me a cooldown appropriate for that. And it builds on and establishes that context. And the reason I do it this way, instead of just floating all that text around and passing it around the whole time, is because of that 256K limit. I want to be able to have an unbounded conversation with ChatGPT. So I just want to make sure that's stored off in a cache. Now, it is important to note that Momento has a soft limit single item size of 1 meg. Now, it is a soft limit. We can increase it if you make a compelling case, but it does go to 1 meg for now. But that's plenty when you're talking about these limitations of these other systems, because that's a 4x increase for SNS, EventBridge, SQS, and step functions, and it's a 2.5 times increase when you're talking about DynamoDB. So it's a lot of data storage. But again, if you run into a use case that you need more than one, we can take care of you. Okay, so super exciting stuff. Hopefully I've got the wheels turning and you understand some of these cooler use cases, that it's not always about databases and fronting that. It's about ephemeral data stored, keeping stuff that's short-lived in a cache for its entire life. I'm going to ground us a little bit. I have to talk about some of the bad things about caching, because it's important. It's really important, because it's not a panacea, or it's not a cure-all. It doesn't fix all of our problems. So let's talk about some of the issues. And one of the big things, I just gave a talk this past Thursday at Serverless London, and I was talking about Momento and about how easy it is. And somebody came up to me after the conversation, and he said, I really wish that I had heard about this on Monday. And I was like, what happened on Monday? He said, I started implementing Elasticache in AWS on Monday, and I'm still not done. And it was Thursday night. He's been working with VPCs. He's been working with provisioning. He's been working with all that inner networking, figuring out how much capacity he needs. And it's hard. It takes time to build that skill. So, you have to figure out with caches, what is that capacity? What is the network stuff? How I say network stuff because it's so confusing and there's so much. And you also have to come up with meaningful invalidation strategies. You want to make sure that you're not passing stale data back to your customers. You need to figure out, like, what do I do when I update the code? I can do a write aside, but is there another way that data is invalid? You have to figure that out. And not only that, caches are expensive. You have to monitor the usage at all time. The stuff that you provision, that cluster that you have to make sure that it's not about to run out of capacity. If you have 50 gigs allocated to your cache and you're sitting at about 40, it's probably about time to increase the size of that storage. So you have to pay somebody to monitor that. And if you have it automated, you still have to figure out how to automate it and do all that. You're still going to be paying for that capacity that you're provisioning. You can implement wrong with cache. You need to be really careful with how things, with how your cache hit rates and your miss rates happen. So let's take an example here. If you have done a really good job with your write-aside caching, so your cache hits 99.75% of the time, it only misses just 1 out of every 400 times. And all of a sudden, you get this influx of requests where you're getting a bunch of misses, and you bump down from 99.75 down to 99%. And now on the surface, that seems like a really small amount. But when we're talking about scale, really what we've done is we've increased our load on the database 4 times because we were only fetching, at that 0.25%. Now we're fetching at 1%. So we've increased that load, which could cause a problem if you have things like provision capacity set on DynamoDB. You can easily go over your read units if you didn't allocate for that increased miss rate. So you have to be very careful when we're talking about that. And then, of course, you have to upskill your engineers. We talked about that guy that spent 4 days learning. He's not going to be around forever. He's going to have to teach other people how to do it, how to maintain it, what the configuration knobs are, and that it takes time. And time, when you're talking about engineers' time, SRE's time, whoever's time, that's money when we're talking about business. So luckily, here's the plug. That's not really a problem anymore. So when we're talking about Momento Cache, Momento is a serverless cache. And when we talk about serverless, we mean true serverless. It's ready in a single API call. I can hit cache client.create cache, get a response back in 300 milliseconds, and I can immediately set a value to that. It's ready. I don't have any thing to configure. I don't have anything to set up or wait to spin. It's good. I can hit it and it works. It elastically scales. So in one of those situations where you have bursty workloads where nobody's using it, everybody's using it. you can rest assured that as part of the serverless shared responsibility model, we have your back on the infrastructure. So we have alarms and automation in place that when a bunch of data and a bunch of requests come in out of nowhere, we can scale that infrastructure in a matter of seconds and provide you, the consumer, with a seamless experience. And probably the most important piece when we talk about elastic scalability, it scales down to 0, meaning if you're not using it, you're not paying for it. You're not paying for provisioned clusters or provisioned servers. You're paying for usage. 50 cents a gig of data transfer, and that's it, plus a 50 gigabyte free tier every month. Super cheap to use, super fast, super reliable, super nice. And we also build in things like automatic expiration to kind of help address with some of that cache validation strategies. You're still going to have to do some research on figuring out how does your data work. Is your data high read, low write? That's a good use case for a cache. Is it high write, low read, and short-lived? Maybe we just keep it in the cache for the duration of its life. Maybe it's something that we opt not to cache. The big thing there is figuring out your data needs. There's not really a blanket one-size-fits-all when it comes to expiration and invalidation. But it's really exciting because it really does work and it really is fast and it's very, very reliable. So that's what I got for you. That's the extended use cases. That's all the caching goodness that I have for you today. If you have questions, happy to field them right now. Also happy to field them later. You can contact me on Twitter, or you can come look at my blog, readysetcloud.io. I have a lot of content on there around serverless. I also have a lot of content on the Momento blog around caching specifically. And if this is inspiring to you, you can actually get started. This is a QR code here to our console page. We just released console last week. We just released SSO this week. So you can sign into our web console with your Gmail or your GitHub accounts and start building a cache literally without any code. You can just point and click in a browser, get set items. 15 seconds, we timed it. It's very, very quick. So thank you all. I see I have a chat here. Okay, Manoj sent the link to the quiz. So happy to field any questions if you guys have any questions for me.
Yeah, one question. So yeah, it was a really good session. So I think I learned a lot about caching. So I think it went far from what I knew before. But one thing was, I think even we talked about this before we started the session, but I think the audience would also find this beneficial. Like, would Momento support any pass-through options? So I saw all of your slides covered a side strategy, right? Even read a side, write a side. So I just want to know if there is any implementation for any pass-through options for DynamoDB or something.
Nope, not at this time. So pass through, just to make sure to kind of level set with everybody here. Pass through, I would define as that's what DAX does. So instead of calling DynamoDB when you implement with DAX, you actually call DAX, and it is responsible for all of that aside caching. It looks at itself first, and if not, it goes and fetches automatically from Dynamo and then stores that data inside of DAX. We do not do that. We have mechanisms to make it easier, to make it feel like pass through, but not at this time, no.
Awesome.
Yeah.
Thanks, Aaron.
Yeah, Alan, it was a really great presentation. By the way, I think this is one of the major gap that we have in the serverless, entire serverless ecosystem. I think serverless caching and the serverless search is like two missing thing. And with Momento and this serverless caching stuff, it's really awesome. I'm really looking forward to test this out. Just a quick question, Alan. You mentioned now this is the true serverless service where there's no any usage, it goes down to 0 and don't have really pay. But in case in the other side, if there are too many concurrent connections comes up and scales up quite fast, if there are bursts and so on. So how fast this Momento Cache scales up? Is it the latency wise? Do you have any numbers or anything? Alan, because that's something I see. So when the serverless services announced, there's a bit of a lag at the beginning, particularly when there's a big burst.
Yeah, I don't have the metrics around how fast it scales up. Like I could like I just want to make sure that I understand the question right. When Lambda gets a big burst, it scales up at about, I think it's about 1,000, it's 600 or 1,000 additional execution environments a minute. So you can have that, increase that concurrency by 1,000 every minute. That's the metric you're looking for?
Yes, exactly. So the Lambda sort of has that burst capacity and burst concurrency, and so that it will like call on the Momento as well. So in such a burst, like Momento is quite able to handle it, I believe, in case of that, I believe.
Yeah, I don't have the growth rate, but I can tell you without a doubt that Momento, the service in general, is able to handle millions of transactions per second. It's a multi-tenant system, so it's designed for ridiculously high scale, and it operates at that capacity all the time.
Superb.
And I didn't mention earlier, but while we're talking about metrics, the SLA on a get when you're in region is 5 milliseconds for an item.
5 milliseconds. All right. Awesome. Yeah. So, guys, anyone has any other questions for Alan?
Yeah, one more thing. What regions does Momento currently have the data centers in? Like anything in Asia per se?
Yep. Yes, we do have. We just recently released support in the Mumbai region for AWS, and we have another. I think it's AP North 1. That's over there. We have also support in GCP regions over there as well. So we have several different locations in Asia that get that code running in pretty close proximity to everything over there.
Awesome. Thanks.
Mhm.